8. This is 1, 2, 3, 4, 5. Wrong file name. This is 1, right? So instead of typing, you use fin and it will read the file for you, same as whatever you type. However, just like in the in here, if you want to read more than one number, you will require multiple fin, right? And way to read on the number in the file, while fin dot eof not fin eof. eof means end of file. Every time you use this fin to read, the pointer will jump one place. So first the pointer can be here, then it's here, then it's here, here, and when it's after I read the number 5, it will be here, right? So at this slide, this is the EOF. So if it is not EOF, fin and the pointer will move up automatically. And I guess something like this. I remove the hello. 1, 2, 3, 4, 5, the whole file. Similarly, for the output, I will also require an out file. So out, I don't need the dot text, but if I put dot text, it will be easier to open in the window. So similar, open. Another way is you can open here. Out, dot close. After close, you can open another file or reopen. Now, instead of cout here, I will f out and nothing here, but if you go to the out file. Similarly, for the string, you will use getLine and fin and s here. F out s will no problem. All right. 1, 2, 3, 4, 5. Even if I remove this, because this one I read from this string, this one not run, because after the f out of the string, this is only in the EOF, so this while loop will not run. And that is the basic of input output in the C++, included the file or input output. Any question?
Sorry, can you repeat the getLine file s?
This one?
Yeah.
So the getLine is function. First variable is the show. So if I want to read from keyboard, I will put C in here, C in, and it will read from my keyboard 1515 ABC. then one file ABC, right? The 1, 2, 3, 4, 5 is the while loop because this time I did not read from the F in the pointer does not move. So similarly, if I want to read I want to get line from a file, I will need this pointer file, the IF stream that point to this file, and replace the cin with fin. I will disable this, so you can be sure that does not run, right? 1, 2, 3, 4, 5, because this is 1, 2, 3, 4, 5. If I change this into University of Technology, for example, and run, this will be out will be University of Technology, right? Or I can bring anything like this, right? So the get line will read the whole line. If I have true line, silent. If I have true line, it will also read one line. And if I want to read more than one line, I will also do something similar to this one. While not EOF. Is that clear?
Okay. Thank you, teacher.
Okay. Is there anything new in this one? No. So some application of the reading from file. So normally you don't want to if you have a matrix or something like I have 5 something like this. I don't want to repeat this reading from keyboard every time I run the function, right? I run the program. Or I have a lot of matrix like this one, so that I want to test it like a test case says. And by using file, I can do this. I will read it from this file every time, and when I have to change something in this file, it does not affect my program. So that is one of the advantage when you're reading from a file compared to reading from this keyboard. So if I read a matrix, I will do something like actually like this. I know the size, right? F in 5, F in n, F in m in n. mn A will be matrix. So 8 and K equals 0, J is smaller than N, J plus F in 8. I big I, J. Right, and every time I want to change the matrix, I will use the window editor or something like this to change my matrix. It is safer than putting this matrix in this program. For example, like this. Right. Well, I have ability to do this thing. Changing in this one is easily to make mistake, and also if I have more than one matrix, like a test case. So if I make a test case like this one, the next matrix can be 4 by 5, like this, and next matrix maybe 5 by 3, so like this, and then it is safer, more convenient to edit, and easier to use compared to doing this B1010 here. So the reading from file is, and also writing to file so that we can read later is important to actually many people in the programming industry or anywhere in the programming, because everything under the file can be written in the XDD, right? XDD. And everything you use when you run the program will be in the RAM, and your SSD is much XDD or SSD. SSD, yes, is much better than your RAM. So most of the time, return it into a file and only call it how to calculate or use later is better. Another way to use this one is using the true dimension dynamic array. Yeah, true dimension dynamic array. This is something like this, and but if I want to use it like this, I will have to a equal mu in n first or m first, whatever, because 5 by 5, right? But normally this should be m, then this is m, this is m, and a star a equal mu in, this is ai mu in n. I forgot to delete out. Delete AI delete 8. Oh my, what's wrong with the file? This one, new file in file 1, 2, 3. I will put file 4. And alpha and nothing. I did not. Nothing. Impact 1, 2, 3. What did I do wrong? But I see in dot txt and 5 and 4 a equal new in m and ai equal new in this one. If our s would not declare. Right. Wrong dimension. M5 and 4. M5 and 4. So M is the line. Yes, M is line. Then N is the yes, now it's right. And if I want, I can draw to the F just file like this one. And F how we could receive the same data. Okay, so that is the input output. Next, we will go with we will move to the pointer and a bit about linked list. So as you already know, the pointer is a data type that can point to a specific data type. So if I have an int pointer, it can point to another integer, right? A equal 5, a equal 8, then cl a0, right? So I can do this. Also, when I plus or minus, the star a will move one slot in the memory block, and depend on the data type, the block can be 4 byte, 8 byte, or anything 2 byte, depend on the data type that you are given to the pointer normally. However, there is some different type of pointer. So if I use the dynamic array, as I already said, this b is like a constant array, right? Cannot be moved, but I use a as now a equal b. So a will now be a free pointer that moving. Now point to the same element as b, same memory block. So if I want to bring the b, I can do something like I will give it some element. Now I want to bring the b 5 element, right? I have two ways. 5 cl a I. This is what you normally do. You will get the 1, 2, 3, 4, 5 as the b right here. Then another way is you run using this a as the pointer. So I have I use another pointer, or just use a. I have a equal b, a smaller than b plus 5, a plus, and I will bring a0 or star, and I will receive the same element. So because the a is a free pointer that can be changed the way the place point to, we can do this, but we cannot do this with the b because b is fixed. So I cannot b plus. I will receive an error. But if I a plus, it's okay. If I move this one like this, what will the second line bring? The second line, what will it be in this case? Okay, it will be 2, 3, 4, 5, and 0. Why the 0 is not here? So because b is fixed, b fixed. So this b plus 5 b plus 5 memory address. B plus 5 memory address is also fixed. So A is plus 1. So it start with number 2 here. The second address, third address, fourth address, and fifth address, and N. Right. So this is another way to move across your array if you want. However, normally people will not be doing this. Another application of the array, the pointer. Sorry, the pointer. The pointer is a function pointer. So assume you have a bunch of function with the same input output. What kind of function will receive same input output? For example, I have this string function. So this is string array. Normally, it's a string array reverse. So I bring from the end, and this is string array. I decide to bring from the end. So normally I will do it like this, right? Reverse equal 0. String array. AN L string array reverse, and I will write the function. This function then I have an array dynamic. Right. Then like 8 and can this run? No. Overall, because I will no more because this is equal 0. So the function does not know what to call. So if I run more, it will bring from left to right. And if I do not more, it will run from right to left. if I put one here, from right to left. So instead of using the two function name here like this, I can use a function pointer. This is a simple case, so it will look more complicated than needed, but the real case will give you better like better traffic. So I have function then in star in n right output input send then function equal string array normal equal and then function equal string array reverse insertion and right I can that is very that's enough and I don't make it more complicated. Some way I can use this is like we of a lot of function like calculator I guess because the input is mostly the same number output function number. And that is the basic pointer and function pointer. Any question on the pointer? Yes.
Teacher, why at the end of the array and the result we have the semicolon?
No need. It's not wrong, but not needed. You're right. Because when I like declare what like this, right? So I did like this, and then we have the semicolon after. That's why it is extra.
Okay.
Zero and definitely no. Any other question? No. Good. So next we will move to the linked list. Linked list is something we made with pointer. So normally if you use the array to store, if you use array to store your data, it will be something like this. Right. Continue memory plan, and the place that occupy the NAS is still here. This is array continuous. However, when you are using the array, it is complicated. The array is good because it is easy to use and faster because it's continuous. And also it's easy to control your memory. However, in case you want to delete number 3, for example, number 3, you will have to do something like delete number 3, right? You will have to copy. This is still the same, right? This is still the same one. So you have to replace number 3 with whatever after it. I cannot click number 4. Okay. Right. Replace the whatever number after. This is so hard. Okay. And the actual number 5 is still here. Just you did not use you reduce the number of elements that you want to use from 5 to 4. But this one is still here, and memory after is still here. In this case, it is still workable, and you don't have to erase any memory. However, the other case, this is really cumbersome, inconvenient, but it can be even more inconvenient when, for example, I want to add 2 numbers. I will put 6 here. 6 here. Right. So if I want to add 7, what should I do? This is remove, right? Remove is a bit inconvenient but workable. But in this case, I want to put 7. I have to how? I have to call a bigger memory slot, at least 7, because I want to add 7, right? Then I have to copy the value of this memory slot to this one, right? Then I have to add the new data that I want into here, and then I have to delete the old array. Until then, I have the new array. Some other conversion is in the middle or in the first place, in the first or in the middle. This is also inconvenient when you are doing it with the array, right? So that's why for some algorithm, if you have to do the delete, remove, insert, a lot of time, the array is not the optimal way to do it. So that's why they will use something, sometimes use, not always. They will use something called the linked list. Why? This is something like this. So they are not continuous in the memory plan. They are discrete. This one point to this one. Ow. And this one point to this one. And this one somehow point to this one, for example. Then I give value 1, 2, 7, for example. 3 is enough. So they call this the linked list. The one from begin here is just a header, a pointer. So this pointer is called the head pointer. This is called the head pointer, and this first whatever pointed by the head is called the head node. So the head with number 1 is currently the head node. This is head pointer. Actually, this one that is actually similar to the. I should not draw it like that. I should draw like this. This one actually have a pointer point to this, right? So this is called the A or B or array. No, normally you are doing it. So this A star A is this pointer for this array. And as previously, as I mentioned previously, the add and the insert and the remove in the array is slow and inconvenient. So how about the insert in the linked list? In the linked list, if we insert a new node, first of all, the linked list don't have the memory limit like array. If you use on your RAM, it's still the limit, but it's not like the array. So if I want to add a new node after number 7, I just make a new node. Right, make a new node first. Then I point out. Then I point the number 7 node to this node. And whatever this new node have the data, maybe 23. And if I want to add a new node in the middle or in the first place, then for example I will add number 3 between 2 and 7, right? How? First I made a new node somewhere in the memory plan. My new node. Then I point this new node because I currently have some kind of pointer that point to this node. That's why I know where this node is. So I first point this new node to number 7 here. Then I cut the link between 7 and 2. The 2 will point to this node instead of 7. So whatever data in this one have, maybe 3. And that's how we add a new node to the linked list. We don't have the memory limitation like this one, and we add in the middle. We don't need to move any, like we have to move everything back, right? If we add something, we have to do everything back. We don't need here, we just move. Okay, then if I want to delete number 3, I just reverse whatever I just done, right? So if I want to remove number 3, I create something, some header that point to number 3, some pointer, sorry, not header, some pointer that point to number 3. Then I point number 2 to number 7. I will cut this, cut to point to number 7. I cut this, and I remove anything that related to number 3, and it disappear. So that is the convenience and the cons, the pros, the advantage of the linked list compared to the array. So how can you make a linked list in this one? So because each node of linked list have 2 components, right? Next pointer that point to the next one, and the data. That's why it have to be class, right? Abstract as a type. So now later we call this node, and this node have data, right? Can be anything, but integer is easy. Then the pointer to next node. This is a type of recursion with the node, not itself, but not important. Not important yet. So fun fact, because this one is made with recursion in mind, the function that work with this one can also be recursive. So I have this node, right? I have this node. I have this type of node. So first of all, if I want to make a linked list, I need this head pointer, right? Head. So I will create a head pointer that point to the type of node, this type. Then I point it to, I create a node to be head. Create a node. My head. This is bad. Because if I do this, the node will be direct, like it will not be dynamic. So I create a node to be the head. Yeah. And this node point 8 point data equal 1, and this head point next equal no. I can leave this out, but no problem. Then I have to create a next node, right? Second node. Node star next node equal new node. Create a new node. Then this next node data equal true. Then head point next equal I will call this current. Next for head equal current. So at this step, right? This is the create head pointer and node. This is the create second node. So next is head point. Next is current. So the head point next is current is connecting the head to the second node. Similarly, we will create more nodes. Now, how can we do this? But normally the add-in is not like this, so I just repeat the right, and then we only have 3 nodes. This is 7, right? 7. Then to count those, we will use the pointer run from equal head. A pointer run from head while ite point next. While ite cout ite point later. And I get struct new node. Ite point next equal ite point next. Go next. Where is my 7? Equal cout white space. Where is this one? Right, 1 through 7, and this is the linked list. That this is basic of the linked list. Normally, we can make the linked list using a class or a bigger struct with more utility, like add function, remove function, something else function, search function, change function. But in the primitive way, it is like this. This is the linked list. More specifically, the singly linked list, because every node only have one link. There are many types of linked lists. There are many types of linked lists, depend on the use case. Sometimes they will have another link that go back from this one to this one. Sometimes this one will have ruling out. This is something like a binary tree. So this one will have true link go out or something. Bring depend on use case. People can modify the data structure to fit the specific algorithm or the specific data. So, any question about the linked list or the pointer?
On the when you create the code node, you didn't use the pointer for the code.
What?
Yeah, okay. On the line set 31,
Yeah.
the code that I actually see that in the second and first it is a pointer to the node, but now it's a whole new node.
Because the current is a free pointer, right?
Yeah.
So I can reuse it and point it into another place. What I done is like this. I will draw it. I will draw it so it is easier to understand. Step by step. Okay. So first I call the head, right? And I name this head, right? This is head. This is what I done. So what next? I head equal new node. So head equal new node meaning this pointer point to a new node. So one slot of memory will be created for the node. This slot of memory is created. This is head equal new node, and the node one node have something like this. I will have this empty node here pointed by the head, and I have data equal 1, right? Data equal 1. Oh, okay. So next step, what did I do? I node star current equal a new node, meaning I just create a current pointer here, pointer. Then pointer this current equal a new node, so I have a new node somewhere around here maybe. That pointed to by the current. So I don't know where this is, but this is currently managed by the current pointer, and I give the data true here. The next step is head next head point next equal current. So the head node currently pointed by head is this one. Next equal current, meaning it point to the same place as current, right? Then I have current equal new node, meaning I did not create a new node, but I point this one to a new node. Maybe around here. Yeah. Right, this is current equal new node. If I name another pointer, I will have another pointer here. This one is current. So the number 2 is not pointed to by current anymore. The current point to the new node only. And the current data equal 7. 7. Then because this number 2 is not in my direct control anymore, not direct, but if I want to set number 2, I have to go from the head currently point to 1, then point from this to the 2. That's why this is head next equal current. That head next equal current will point this one to the same place as the current. Something like this. So finally I have something like this. The current pointer is actually still here because I did not delete it. Then I create a new node called ITE. So a new pointer ITE. So ITE will be somewhere around here and point to the same place at the head. Point to same place at the head, meaning number 1. And go to the while loop. While ITE, meaning while ITE is pointed to something that is not no or 0 or something not known, because you will know later. So while ITE CL ITA data, the first loop will be CL number 1, right? The second loop, meaning ITE equal ITE point next. ITE equal ITE point next, meaning ITE this pointer here will point to this one, same as this one point next, same as this pointer. So now it will point to this one instead of the first one, and bring it. Then again, ITE equal ITE point next. This time it is 7, right? I want to delete the small one inside. Okay. Then bring 7. Then ITE equal ITE point next again. Some compiler will default it at the node here. So next time ITE will point somewhere around here, which is nothing, right? Nothing. So at this time, ITE is nothing. So the while loop end and the program end. So anything not clear?
Okay. I just one more question is that because curve you in the second node curve equal new node, and also in the third curve equal new node. So this might look like a little bit familiar. So will the compiler will differentiate these by the time they appear?
Actually, this new node and this new node is different, right? Because it is the new syntax. It will give another memory slot, not the same for sure. So that's why this current equal new node and current equal new node is 100% different. Even if I use the next one, right? Like this, number 3. It's here and add next, right? Then it will be 1, 2, 3, 7, 3.
Okay.
So they are actually different. Normally, this one will be this utility will be in a function. This is repeated work, right? So normally you will put it in a function.
Okay. No.
For the more specific of the implementation of the linked list, I have put this file linked list in the course material, which have a template class way of implement a list with some basic function like where is the add? Did I open the wrong file? This one, yeah. So this one has some basic thing like search, destroy list. Where is the add function? Insert function. Insert is add. So insert function. Insert in the linked list will have 3 special place, which is in the beginning, in the middle, and in the last place. And delete, same as this one, and clone if need, but normally you don't need clone. So you can, if you want to try and implement the linked list, you can refer to this one. Where is my site? This linked list one. So any other question? Anyone have question? So good. So in summary, the linked list is something that can add or remove this single linked list only. Is something that can add or remove the node easier compared to your normal array. However, because all of this is pointer, so when you implement the linked list, you have to be careful with controlling the pointer, and also you have to always keep this head, always keep the head pointer to this head node. If you lost this one, lost the head in this kind of linked list, you will not be able to delete any place in the linked list, or at least from the head. If you make the head into this current, for example, the head only point to this current, so you only lost number 1. If you have the hash point to 7, you lost number 1 and true, and you cannot find it anymore until you restart the system. This will cause memory leak. So until you restart the system, the memory leak will be there with you. So be careful when you are using that. And for the utility of the linked list, you will have something like accessibility, add, remove, change data, search a data, or something just like the array. So whatever you can do in the array, you can do it normally in the linked list. The end product is the same, just that the procedure, the middle way is different, because in normal case, like the matrix or the matrix, when you calculate the matrix or something, the array is much better because the size is set. Most likely it will not change. But in case where the memory or the slot have to be changed, or the data have to be moved around, like in a sort algorithm, the linked list will be better in that case. Especially when you have to remove a node or something, the linked list will be better. And that is the basic of the linked list and pointer. Any other question? Okay, if there is no question, we will end the class today here. For the student who come late, I create the power subfunction that I mentioned in the last class or before the holiday. we have the loop version, the recursive version, and indirect recursive function version, and some tests here. I can run it here. Right, loop, recursion, and indirect recursion. The output is the same, of course. Okay, if there is no other question, I will end the class here. See you next week. Next week we will learn in the class normally. I think we will do an OOP basic or some practice project. Yes, that's it. See you next week. I will remove this